I was talking with my mute on. I was just introducing Derek. I'm going to be serving as moderator for this session, but Derek Runberg, who is an educator with SparkFun, he will be leading the session. And I don't know if that's your right title, so please feel free to correct it. But I will now pass on over the show.
Perfect. Thank you so much for having me. Like I said, like Anita said, my name is Derek Runberg. I'm going to kind of introduce myself and SparkFun. If you haven't worked with us before, Arduino is new to you or anything, all of this stuff is new to you, that's okay. We're going to start from square one. I'm going to be going between slides, 2 different webcams, and sharing my screen in multiple ways. So just bear with me on that. I know we're all have been in that situation over the past couple of months. So it might not be the prettiest transitions, but we'll get there. If you have questions, please pop them in the chat. Anita, can you help keep track of things? Because I got a lot of things going on. If I will stop periodically to kind of field some of those. But if there's any burning questions, feel free to interrupt. I'm going to do kind of an overview. I'm going to do kind of what an Arduino is, what's in the recommended SparkFun Tinker Kit, which is kind of what my recommendation is for Mesa. And then we're going to do some live coding with an Arduino so that you can kind of at least see what the experience of programming with Arduino looks like. So with that, I'm going to jump into some slides. So for all of you, this is my contact information. So my email address, and that's directly to me. So there's no email filter, nobody looking at them and filtering them for me. I'm available roughly 24/7. I probably actually these days more or less 24/5, I should say. But if you have questions, if you have issues, you don't know what to buy. So this is both from a customer service perspective in terms of purchasing things and what sensor should I get, or my students want to do this and I don't know what part works. I'm there for you. That's what I'm there. If you have questions about how do I teach something, right? If I have this concept, it looks like, you know, in the guide, but my students aren't getting it, bounce questions off of me via email. I'm there for you. If you want and you're looking for someone as a guest speaker or presenter to your students, I can do that as well. I know there's some districts that have a lot of restrictions on that these days, but I'm up for doing some type of presentation for you. Again, I'm up for it. If you have that question, feel free to throw it out there and we can go from there. I've been with SparkFun Electronics for 8 years now. Before that, I spent 5 years as a middle school technology teacher in Oregon. I was also a Mesa instructor for kind of their summer programs, spring break programs for a couple of years as well. So very familiar with Mesa, but also familiar with using this stuff in and out of the classroom as well. I taught Arduino in my classroom, as well as another programming language called processing, which is similar but different. And we'll talk a little bit about that later. But a lot of this comes from my classroom experience, and I know that classroom experience doesn't always align to Mesa experience depending on how your state is formatted. So take what you will, but I'll also be speaking from my perspective of Mesa as like an after-school program. So today I'm going to introduce SparkFun for all of you that were new to you. Our approach to this, we're going to talk about Arduino. So in the last session last time, I talked about Microbit, which is another microcontroller platform. If you're interested in that, I know that they recorded it so that you can go back and watch it later on. We're also I'm going to do a basic demonstration and walkthrough of the process of building a circuit with Arduino and then programming it to do something. And the best presentations are the presentations that have lots and lots of questions. I want you to ask them. Otherwise, it's just a bunch of all of us awkwardly staring at one another through our webcams. So please ask them. little bit of reiteration of goals. SparkFun Electronics has been around since 2003. And we started as essentially someone as a side gig, a side hustle for a college student at CU, which is our founder, Nathan. He was an electrical engineering student, found that he had a hard time finding parts for his classes, and his fellow students were as well. And so he actually decided to start buying a bunch of parts up, taking really good photographs of them and writing some example code and hookup guides for how they all work and posting them online for resale. So he maxed out his college credit cards to start up a business. And from that dorm room, and there's photos of him doing shipping out of his dorm room, all the way through, we now are in a new building that was built in 2018, I think. No, 3 years ago, 2017. That we've expanded both the availability of electronics to everyone, hobbyists, students, teachers, inventors, engineers, but also demystify them. And that's kind of our bread and butter, is that demystification factor. We did, a while back, we did a national tour of professional development in classrooms. So you can see the RV there. We drove around. I think we taught in 45 of the 50 states, 80 professional development stops in, it was like 160 days. So it was pretty brutal, especially when you count driving an RV around the country. And since then, we've partnered with a number of districts, a number of grant projects, as well as Mesa in 2014 or 15 at bringing electronics to the prosthetic arm challenge. And since then, SparkFun parts have been a part of Mesa and continue to do so. And we're just honored to be a part of it and continue to learn from one another and bring computer science and programming to students. Again, if you've never seen us, if you've ever been to a maker fair or maybe a hacker space or a maker space, we tend to build all the electronic guts that go into some of these projects. If it's a red circuit board, it's probably SparkFun. We also provide, from our educational perspective, we provide curriculum and professional development. So we've done a number of professional development workshops with Mesa before. We teach at different occasions, virtual presentations like we're doing now. We also then provide materials and kitting. So if we do custom kitting, we do, if you have a kit in mind that might be one of our kits, but you want a few things here and there, we can do that for you as well as providing instructional materials around those. There we go. We approach the education technology as the idea of approachable ecosystems. And the three ecosystems that Mesa focuses on, or actually two of the three, are ones that we majorly support. So the microbit we presented before, we have a number of kits and expansions and things like that that work with the microbit. We're focusing on the Arduino with our SparkFun Red board, which is the board in the middle. And this has an entire, what I mean by ecosystem is that it's not just a single product. It's product that you can use to explore a number of different things. So we have a robotics platform that's programmed in Arduino. You can go build a weather station that's programmed in Arduino. All of these sensors work with Arduino. Even our digital sandbox to the left doesn't look like an Arduino, but it's programmed in the Arduino programming language. So that there is this ecosystem you can start in as early as late elementary school, and it goes all the way up to people are using these components for work in universities and research. NASA is using SparkFun components, things being sent up the International Space Station. There's a lot of our stuff in weird different places at all levels of professionalism. The recommended product that I recommend to MESA instructors is the Tinker Kit. And what this is, it takes our flagship, our SparkFun Inventors Kit, and makes it a little bit more affordable and gets you kind of the core components that you need and that your students need to get started in terms of starting to tinker with Arduino in terms of the national challenge. What's in this kit? Oh, sorry. We'll talk about the ecosystem a little bit first, and we'll jump into what's in there. Before I do, I want to pause. I know I've seen some alerts for questions or comments. Anita, do we have any major questions?
No, the one question was if they could share your contact information with their students, but there was nothing else related to content.
Ah, good question. I would highly encourage you to please keep my email address to yourself. I sometimes will help students periodically, but it's best if you can kind of translate their questions for me, and then we can work through that way. I like to try to keep a professional buffer between me and students, if that makes sense. Arduino ecosystem. So when you compare this to the other ecosystems, and you might have heard, so the microbit, but there's other ecosystems, so like the Raspberry Pi, for example. We're going to talk about the advantages and disadvantages of the Arduino ecosystem, the one that we're in the workshop for. A couple of advantages. There's a huge community and a lot of examples and content out there. Not only to inspire students, but stuff that's completely achievable and accessible for students. If you just Googled Arduino, you're going to get over 1 million hits. It's probably actually way more than that. It's just been around since 2001, 2002. It's been around longer than our SparkFun has. And so there's just a lot of content out there, and it's ridden the wave of how the internet has changed since then as well. So really, as the internet's been this platform for sharing content, their body of content has also grown. There's a huge product offering. There's over 100 different Arduino boards. So the controller board itself, there's 100 different versions, which sometimes is daunting, right? Which one do I buy? It's probably the #1 question I get. But there's a lot of choice, and what that means is there's a lot of flexibility and choices for size and computing power and price options for you out there. It's relatively cheap and replaceable in terms of both the controller board and components. So if you compare this to something like Lego Robotics, right? Your Lego Robotics kit is roughly $300 these days. You get a lot with it. You get a lot of Lego bricks and components, but that controller brick makes up the majority of that price. Compared to something like our SparkFun Red board, which is around $20, there's a huge difference there. Now, there's a huge difference of experience for students, but there's a big difference. And then all of the components that work with the Arduino are legitimate components that you can find not only on SparkFun's website, but you can find on Amazon, you can find it anywhere, and they're real electronics components. And so if students are working with the Red board and Arduino, and they open up, I have a half torn apart printer sitting here on my table, those components are the same components they would find in a printer. And there's something authentic and powerful about that for students. The software to program an Arduino in is free. So there's both a web version that if you're a Chromebook school district, you'd be probably using, as well as a downloaded and installed version of Arduino software for both PC and Mac. All of it's free. And there's a number of curricula out there. So a lot of people have been using this in the classroom for the past 10 years or so. There's a lot of content out there. You just need to look. And it's real life electronics. So those are kind of the advantages of that, is that students get to look around, and like I said, they can pull a PCB out of an old piece of electronics or an old product, and they can start to identify parts that they've used themselves before. Some of the drawbacks for this is that the software does need to be installed. for those of us that are teaching still remotely, which is probably the majority of us, that's a difficult task for our district IT teams, let alone getting it back out to the students. Breadboarding, which is, you'll see how we prototype circuits and build circuits with Arduino, can at times be complicated and time intensive in terms of the amount of instruction you need to give. But there's ways around that, and it's taking baby steps and patience. It can be relegated to the technology classroom or technology class. Like using this in science class, you do see from time to time, but it's one of those things that just kind of gets pushed on the technology teacher. It's text-based programming. So if your students have never programmed anything before, and what comes with text-based programming is correct syntax and spelling. So you can't do LOL. Arduino won't make sense of texting shorthand. So things need to be spelled correctly, and there's spacing issues and all that stuff. So that's to overcome, but I think that's also part of, in general, building up students' tech literacy skills as well. And like I said, it's not super Chromebook friendly. It is workable through Arduino Create. We can talk a little bit about what that looks like later. But the ideal solution is installed software on the machine the students are working with. Here's a video. I'm not sure if the audio is going to play through Zoom. We'll try it and we'll go from there. So I'm going to play this, and let's see here. Anita, just give me a yes or no if it doesn't work.
The SparkFun Tinker Kit is an upgrade to the Mini
You're good.
Inventors Kit, where we've mixed in lessons learned from the Educator Mesa Kit. It includes all the components you need to get started with pushing buttons, lighting LEDs, reading sensors, driving motors, and turning servos. Additionally, it includes a battery pack holder, so if you want to power your project without the need for a USB cable, you can just add some AA's. A full online guide walks you through setting up and using the Tinker Kit with 11 different circuits. This includes things like making a night light, and controlling the speed and direction of a motor through user inputs. The Tinker Kit is a great way to get started with the Arduino platform, whether you want to explore interactive art displays, record the world around you, or start playing with robotics in preparation for SparkFun's autonomous vehicle competition.
All right, thank you, Sean. So that's kind of a short introduction to the Tinker Kit. I'll leave it as a video so that if you wanted to share it with your students, you can, and show it to them so that you don't need to find your own words to describe what the kit is. I'm going to switch webcams here really quickly because I want to go over the components that are on the Arduino really quickly, real time, without me having to use my mouse. So I'm going to actually switch webcams and stop sharing my screen for a moment. Stop share. Knit. And move this out of the way. So this is a SparkFun Redboard. It's plugged in right now. I'm actually going to unplug it so that we can look it up close and we don't get blinded by LEDs. Perfect. So this is called a microcontroller. A lot of people will call it a development board or dev kit. It's all kind of the same thing. And what it is that right here, this black square is what's called a microcontroller. So you might hear the term microprocessor, microcontroller. They're relatively the same thing, but think of this as a baby microprocessor. A microcontroller is a microprocessor that can only do one set of instructions or one program at a time. So instead of the microprocessor that's running the computer that you're all sitting at right now, that can have Zoom open, your email open, Facebook, all this other stuff. Maybe you're playing a game while you're listening to me. Sure. All of that is what's called multi-threading. And those are all programs running simultaneously at one time. It's essentially multitasking. An Arduino, a microcontroller, can only do one thing at a time. And it does it in a loop over and over and over again. And it's designed to control physical things. So we connect physical things to this brain via pins. And I can't zoom in any further, but what you can see are these little tiny little legs coming off of the microcontroller. And those are called pins. And they're extended and made more useful by these ports that are down either side of the Arduino, or the red board. So our version of the Arduino is called the SparkFun red board. This is the same thing as an Arduino Uno, just a different color. So you have these pins. So when I refer to pins, and they are numbered, as you can see down the side, you have power, like a power rail, like access to power and ground. You have analog inputs, A0 through A6, I believe, off the top of my head, A5. And then you have pins 0 through 13 on the other side. So as we start to program this, the way we tell the Arduino to control a specific pin is they're numbered, and we can cross-reference that in our piece of code over on the right. We can power the board two ways. We can power it over USB, which is what I was doing when I turned on the camera, as well as a barrel jack through a battery pack, which you saw in the video. Looks something like this. 4 AA batteries. You can use rechargeable AA's if you want, but it's just a barrel jack. It also, you can plug this in with a wall charger as well. So that's how you power it. There are some LEDs or lights on the board as well. 2 of them for showing if data is going to and from the Arduino. They're called RX and TX just for your own reference. And then one that's 13. And that 13 is connected to pin 13 over here. So whatever we do on pin 13, that light will light up on and off. And this pin 13, this light on 13 is a great way. It's the first thing we do when we start to test or turn on our Arduino, is that we actually get that thing to blink. There is a button up here in the corner, which is the reset button. So if you had an old computer or PC in the, let's say, mid to late 90s, you had a power button or power switch. You also had a reset button. And that's exactly what this is that it starts the program over again from the beginning. So sometimes things get hung up and it's not doing necessarily what you want to do, and you want to start that program from the beginning. You can press that button and restart it. You can also restart it by just unplugging the power and unplug it, plug it back in again. But that's the SparkFun red board. Relatively, it's about the size of a deck of cards. Any questions so far in terms of what this thing is and what does it look like? No. Cool. I am going to go quickly back to our slides. Now the kit comes with not just the red board, but also a number of outputs. Outputs are things that it can use to do things. So we can control motors with it. So these 2 motors that are in the middle are continuous rotation motors. They're what you would imagine as a motor that would be pushing a remote control car or a robot. But these can be things like that. You can hook up a spool to it and spool up and pull in and let out cable or wire or string. There's a servo motor, which is think of it as a smart motor, which I can tell it to go to 90 degrees and it will turn to 90 degrees and it'll stay there until you tell it not to anymore and go somewhere else. Think of servo motors as the speedometer on your car is a servo motor. So as you speed up, the computer in your car sees the speed and it turns that servo to an angle that's allocated to your speed of the car you're driving in. You have LEDs, lights of different color, red, green, yellow, blue. You have a buzzer, so you can program the Arduino to make noise or play music. And you have an RGB LED as well. So red, green, blue LED is if I took 3 of these LEDs, this red, this green, and this blue, and put it into one. And you can think of this RGB LED, or red, green, blue LED, as a single pixel from a Jumbotron. So you think of a Jumbotron at a sporting event, or maybe your TV if you get up close, a single pixel, and I can program pretty much any visible color that I want using that LED. So I can have one LED that it be green one moment, and then I can program it to change, and it can be blue or teal or purple the next. There's a number of inputs or sensors in the kit as well. So in my upper left-hand corner is a temperature sensor. So it can sense the ambient temperature of the world around it. There's a switch, a light sensor. You saw Sean build a nightlight in the video. This is the light sensor that he was using. There's a potentiometer. Potentiometer is just the fancy term for dimmer switch. So if you have one of these in your dining room, right, you can turn the lights all the way up to me doing homework and it being my home office during the day, and I can turn it way down for romantic mood lighting dinner for 2, right? So that's that same type of switch or input that you have there, as well as some buttons. So we give you 4 buttons of different colors. But the backbone of this kit are these 4 things. So you have the breadboard, obviously, we talked about that already, but you have a breadboard, which is this thing. And this is the prototyping space of the electronics world. So this is like your piece of paper if you were in art class. Very, very important. It is probably one of the bigger hurdles for teaching electronics to students is how to use this in an appropriate way. But once your students get it, this is their world. A USB cable. Ours comes with a SparkFun Red one, and it is a mini B, not micro B USB cable. And a battery pack. So one of the things, once you upload code to an Arduino or a Redboard, that code lives on this chip. That set of instructions stays here. It doesn't live on my laptop anymore. And so what I can do is I can actually disconnect it from the laptop and I can power it separately. Just like my braking system in my car is run by a microcontroller that is not programmed or not hooked to the computer that it was programmed on. And so we can power them separately, like I said, using a battery pack, our USB cable if we wanted to. And you can even use a USB cable with like a USB battery pack for charging your cell phone as well. And then how do we connect the Redboard to the breadboard is through jumper wires. And these jumper wires, just like any other wire, so it's insulated wire, and they have these pins on either end. And I can plug one end into a pin on the Arduino and the other end into the breadboard. And I can build circuits using the breadboard in combination with the red board, Arduino, back and forth. Sometimes this gets messy. There's a lot of wires that go between the two, but that's the nature of the beast. And there's some strategies you can have in terms of keeping things clean and minimizing wires, but that's kind of the world of electronics. What comes with the Tinker Kit as well is a 11 experiment guide that walks you through all the way from kind of what we're doing now in terms of what all of this is through using every single component in the kit. It also includes how to install the Arduino IDE and all the drivers and everything else. So that where you see install or the Arduino IDE, it's very important for, well, one, you, if you're able to install the software for yourself, but two, your IT team, if you need their help to install it or need them to install it. Those are all of the instructions for how to do that. But from there, we take in a progression from blinking an LED, which is kind of our introduction, all the way down to driving a motor with inputs, which is probably the most complicated and most wire intensive thing. By the way, if you have questions or you find issues with this, I am the author of this, so I can make changes, clarify, all that stuff for you. So that's all fine and dandy in terms of walking through things, but I know as a teacher, a lot of us are like, well, we want to teach some of the background of this. Like, what is an LED? Like, students are going to ask me these questions, and what are my answers? Well, we have in every single one of those experiments, there's background information about what is an LED. We take the time to sit down and explain that through our content. What is a resistor, so that it makes sense. And then we give you very clear wiring diagrams, like this is how to hook up an LED the proper way. And then example code of getting it to blink. And we're going to do this here live in a bit. But that's kind of just, that's the hookup guide. And then this is probably the scariest part for instructors is one, if my students finish quickly, what do I have them do next? We give you a set of challenges that you can pose to your students. But two, troubleshooting. I'm not an electrical engineer. What am I supposed to do? How do I help my students? And so we give you a troubleshooting guide for each circuit of here are the basic problems that we see, and then here's some possible solutions. Now, not every problem and every solution are going to show up in this troubleshooting guide, but it gives you at least a good start. Gives you a comfort level. For those of you that have done this for a couple of years already, that have some experience with Arduino under your belt, and I only bring this up because people might see this on our website, and so that I wanted to be very clear with you. We have a system called the SparkFun Quick system, and this is a series of more advanced components and boards that plug into your SparkFun Red board. It's, again, they're more advanced sensors. They're very easy to use because we made them daisy chainable and they can plug into one another. They tend to be rather expensive because they are more advanced sensors. But if you're looking for a very specific functionality that you cannot find in the kit or any other component, this may be a really good opportunity for you and your students to kind of stretch a little bit into something like a barometric pressure sensor that doubles as a very high quality temperature sensor, or some type of display, or, you know, I know that things are relatively open now in terms of the challenge this year, in terms of how broad of a topic it is. So things like, you could even hook up something like a GPS, which are getting more and more affordable these days in terms of being able to hook it up to an Arduino. So that's what that is. Again, I recommend if you're thinking about incorporating Quick into Mesa and Mesa project, please reach out to me so that I can help you best find what's most affordable and make sure that it works for that application.
Derek, I did have a question on the power source on there.
Yes.
Will the Red board still work with the 9-volt battery? Sometimes students say that the battery pack does not provide enough voltage.
So a 9-volt battery provides a high voltage, but the current is not great. So 9-volt battery, even though it's a higher voltage, it's a lot of times the battery will die very quickly because it doesn't have enough current to run, for example, 2 motors. So there's a give and take with a 9-volt battery. Most things that students are going to do, for example, run a robot or things like that, will operate off of 4 AA batteries. I'd be very curious to see what they were trying to do that they couldn't use 4 AA batteries with. Yeah, most things should be able to be fine with 4 AA batteries. Perfect. I do have a shameless plug. Part of when I came to SparkFun and out of the classroom was to document the work that I did in my classroom in the form of 2 books. One of them is an Arduino Inventor's Guide. The other one is the SparkFun Guide to Processing. If you're looking for projects that are not breadboard centric, like in terms of lack of context, the importance of projects with these is that the students understand what they're doing and not just blinking LEDs, but like where could those LEDs be used. The Arduino Inventor's Guide is essentially the guide that you're doing with the Tinker Kit or your SparkFun Inventor's Kit, but through the lens of building projects with hot glue and popsicle sticks and cardboard to build real projects. So I highly recommend getting at least one copy for your classroom to just be able to flip through and give both you as well as your students some inspiration and some project ideas. So with that, I'm going to pause for questions again, and then I'm going to switch over to, let's do some wiring and some programming and get things going. Okay, so there's one question. Will the red board still work? They tried to make a water pump and also use, so the question about the 9-volt battery and the versus our battery, the battery pack that we include, some motors require much higher voltage than what you even get out of 4 AA batteries, which is roughly 6 volts. With that situation, you need to look at the specifications of that motor and then find a power supply that works with that. And one of the things that I might recommend, if it doesn't have to be mobile, I'm going to drop stuff all over the place, is something like this, which is a wall power supply. It has a barrel jack that fits the Arduino. And when you look at the label on the power supply, I can see that this is a output of 9 volts. Sorry, I'm going to probably, there we go, 9 volts DC power, which is good. And so that gives me much more, and I can put into the breadboard up to 15 volts. Okay, so 9 volts, 10 volts, 12 volts. You can actually hook up a breadboard Arduino to a car battery. So that's a 12-volt battery. So you can actually hook those up. Yes, it's a DC converter. I call it a wall wart because it just a name for it. So. Perfect. So let's get programming, or let's build a circuit first, and then we're going to program it. And Anita, how are we doing on time? I don't have a clock in front of me.
We have about 18 minutes.
Sweet. We just enough time. So I have a breadboard in front of me. I'm going to do a circuit 2 ways. It's like cooking. One, I'm going to do a really quick way without the breadboard. And then we're going to move it over to the breadboard really quickly. And all I need is the breadboard itself. And I'm going to grab an LED. And I'm going to plug this into my USB cable. It's plugged into my computer, so everything will start up here. And I have this pin, this LED on pin 13, and it's blue and it's on. Now I can program the Arduino to just control that LED on its own to get things moving, but I can also do a really quick circuit hack. And I have an LED, and it has a long leg and a short leg. Long leg is positive, short leg is negative or ground. These are called anode and cathode, but we don't need to know that right now. Positive and negative. And we're going to put the positive leg in pin 13 and the short leg into ground or G and D right next to it. And you'll notice that LED turned on and the pin 13 LED turned off. And what happens is that I just replaced that LED with the one I just inserted. This is a quick way to get things up and running and students to build their first circuit with one component. And you're not using a breadboard quite yet. And so we're going to actually program this to blink with Arduino, and then I'm going to move it to a breadboard in the next 15 minutes. So I'm going to share my screen again, and I'm going to move over to the Arduino IDE. So Arduino is both hardware, which we talked about, but also software. And the IDE is just an environment in which I type out the instructions for the Arduino in a human readable way, and then the IDE can take those instructions and turn them into machine language that the Arduino understands. And there's two parts to a program: void setup and void loop. Void setup, whatever code I put inside of here, will run once and only once when the breadboard, the Arduino, is powered up. Void loop will run over and over and over again in a loop until I tell it to do something else or I turn it off. So we have some code that we need to put into void setup so that the Arduino knows what pins we're going to be using. And so we use a command called pin mode, and it has some parentheses and a semicolon. This is all programming syntax. And pin mode needs two pieces of information. It needs the pin number that we're going to use, which is 13, and it needs, is this going to be an input or an output? And it's going to be an output, and it's all in caps. So notice that these things change color sometimes, and that is the proper syntax for that. So like the M in pin mode is capitalized, and that's just information that I know from programming in Arduino for so long, but there's reference for it as well. So if I right click on it, I can actually find in reference, and we'll get the instructions for what pin mode does. So pin mode, pin 13 is an output. That's our only piece of information in setup. So now we're going to go into void loop. And to turn this LED on, we use digital write. And digital write takes two pieces of information as well. It takes the pin number that we want to control and what state we want it in. So the two states that we can have a pin in terms of a digital pin is either on or off, which is either high or low. So I'm turning the LED on, which is high. And then I'm going to use a function called delay. And this is telling the microcontroller to wait. So I'm going to tell it to wait for 1 second or 1,000 milliseconds. And then we're going to turn it off again. 12, how about 13? And off is the word low. And then we have to tell it to wait again for 1,000 milliseconds. The importance of the delay is this. The microcontroller can do lots of instructions per second. In fact, so fast that it can turn this LED on and off fast enough that our human eyes can't see it happen. And so we have to tell the microcontroller to wait and slow down so that we can actually physically see it turn on and off. So it goes on, waits for a little bit, off, waits for a bit, and then it goes back to the top. We have our instructions, they're done. I now need to pick two things from the tools. I need to pick the board that I'm programming, which I chose the SparkFun Red board, which is, I can go to SparkFun AVR board, SparkFun Red board. And then the port it's connected to. I'm on a Windows machine, so it's going to say COM and then a number. If you have multiple COM numbers on there, it's going to be the highest number option. For Mac users and Chromebooks, it'll be like dev/dev/tty/ and then like a random letter and number set. So it looks a little different, but I'm on COM6. And then I'm going to click upload, which is this arrow. And it's going to compile this. It'll turn it to ones and zeros that I don't actually see. But you can see down here what it's doing. So it's compiling sketch. And then it will upload it, and you can see these two RX and TX LEDs blinked really quickly. That was the code coming onto the microcontroller, and now my LED is blinking. On for a second, off for a second. If I wanted to make this blink faster, I can change this 1000 to 500, so I can half the amount of time. Oops. And I can re-upload. Again, it will compile and then send it to the breadboard. Now it's blinking all that much faster. So what this looks like on a breadboard is I can actually take this out and notice that the LEDs now, the blue LED is blinking now. It's still functioning and running its program. I just removed a part of it. And I'm going to grab two jumper wires, a red one and a black one. And the first thing I'm going to do is plug in ground into the black, or the black into ground, I should say. Make sure I get this in the right one. And plug that into the breadboard. And so now I can actually take the LED, and I have the long leg and short leg. I want to plug this in so that the short leg is in the same row as the black wire. And then I'm going to take my red wire and I'm going to plug that into the same row as the long leg and then to pin 13. As you can see, I've completed that circuit and now my LED is blinking again. So that is how we move it to a breadboard. Now, if you compare this, how I just wired this, to maybe how you'll see it in the guide, you'll see something that's called a resistor in between kind of the power. It's in line with the power in the long leg of the LED. And that is the electrical engineering way for doing this properly. For a first time building this circuit, this is probably the simplest and most straightforward way to do it with your students. And then from there, we can teach the importance of adding an LED later on. Think of the resistor as a way to, so if you've ever filled up water balloons and you turn the faucet up way too high and the water balloon fills up really quickly and pops, that's what happens if we put too much current through the LED. And so the resistor helps keep that current at a safe amount for the LED so that it won't pop the LED. Whew. So that's programming an LED to blink in Arduino. Again, we got to see both the, go back to this so you can see me. So we got to see the hardware, what it looks like and what it does, a breadboard, the basic example. We've gone over the kit and what's in it and the kit guide. Right now, I want to just open it up to questions for the rest of the time and be able to field those as much as possible with the time we have left.
There were two earlier questions. One was just, does Arduino have any alignment with Tinkercad just because the name of the Tinker Kit and Tinkercad are similar?
No, not that I know of. I know that Tinkercad does have, you can find like an Arduino footprint in Tinkercad so that if you're 3D printing something or like you can find the size and specs of an Arduino, but I don't believe you can program anything in Tinkercad for Arduino.
And then there was also a question, if you're able to pop up in the chat about the programming. I don't know if it was just a statement or if it's a question in there.
Let's see here.
About how it's similar to microbit.
So on start, so microbit is programmed in a language called MakeCode, and it has two main blocks similar to the void loop and void setup. In MakeCode, which is what the person's referring to, is there's on start, which is the same as void setup, and then there's void loop, and the loop block are the same. So you can actually, there's this, the structure there is exactly the same. It's just they're called slightly different things. And I know Anita just posted, like my last session, there is a survey, so please fill it out. This is the only way I get feedback as an instructor anymore. I don't get students to throw things at me anymore or all that stuff. So this is the only way. Anita can't even throw anything at me right now. So I want to be a better instructor, so please give any feedback you have. For my sake, and I know just making events like this better as well, feedback is always welcome. So please take your time to do that. Perfect. Any other questions? We got 2 minutes, I think. No? Yes.
I have a question. I'm teaching 7th grade, some students 7th grade and 8th graders, and as a teacher, like it's really I'm struggling teaching the language of our programming. Like for example, when to use start, when to use loop, and there's like delay. So those terminologies is really hard. So what's your suggestion, like for a new teacher?
Yeah, so there's a couple of things with Arduino. One, because you're struggling with a couple of issues at once, and that's the problem. When I was in the classroom, I had to kind of like rewind and figure out like, how do I isolate individual specifics? From a programming perspective, look up processing.org. And processing is a programming language that you'll find is extremely similar to Arduino. But what it does is that the students are programming something that you're building something visually on the screen, similar to Scratch, but it's text-based. And that will get them used to programming with text in the same syntax as Arduino without also having to struggle with hardware. So a lot of times if it's a whole day workshop, we actually spend a good hour in processing just to get teachers used to text-based programming using processing. And then that transition to Arduino, since the syntax with semicolons and camel casing and all that stuff is the same, it's a very smooth transition. So what I'm saying is don't jump into hardware too soon, and that will help you with that. Also, feel it is okay. It's actually a good thing to do is start with example code and have them just start changing numbers in that example code or changing a few things here and there. Don't give them something to start from scratch. The idea that information that they can change is then going to lead them to, well, what if I do this over and over again? Or change this to an extreme, and then they'll get an error. And then the question is, what did you learn from that error? Not, oh, we did it wrong. Like programming, there's never a wrong way to do something in programming. It is just, it doesn't work. We got like, how do we change it? How do we modify it? How do we do these things? And so there's always those happy little mistakes.
We do have 1 minute left before we have to close the session, just because I have to go into the next one. But there is one question about in the chat about where can I get some simple circuit instructions for maybe like entry level, like for elementary students?
For elementary students, I would recommend doing some squishy circuits. So you can Google squishy circuits. Those are always really fun. Circuit blocks are also something that is a pretty good thing to look at as well. But that type of, yeah, those are the two things that I would look at for elementary students. Anita, you're muted.
There. Thank you so much, Derek, for
No problem.
you all for attending. I did put in the Survey Monkey, the link and the for the survey and attendance into the chat. So please make sure to complete that. I will stay on for a minute or so to make sure so that you can capture that link. So if you want to go ahead and please open it right away so that I can, I will close out the session here at 2:15. But the next session is just right away. If you can just do a quick Zoom switch, you just basically hop on over from here to our closing remarks, and then we'll wrap up the conference. So once I end here, I'm going to start up that second room and we'll just end with our closing session. Thank you all.
Thank you all. Have a good rest of your day.
One last time, if you haven't grabbed it, please do. I'm about to close the room. See you all in the other session.